Good morning, Group V students. Hope you guys had a good weekend. Today we're going to go through our test review because your test is on Wednesday. But before we do, I wanted to show you a cool app you can download on your Chromebook to get an actual graphing calculator so you can use it on your test. Okay, so to get the graphing calculator, first thing you'll need to do is go to the calendar for today's date, September 14th on Canvas. And you'll see it says read how to install TI-84 calculator. So once you click that link, it's going to pull open this page that gives you instructions on how to install the calculator on your Chromebook. The important thing is that you're on your school Chromebook to do this because it will not work otherwise because the license is purchased through the school, so it has to be on your school Chromebook. So just make sure you're on your Chromebook. Go to where it says type, click the link, and when the link pops open, it's going to go to a Google Chrome extension. And you'll go over to the right-hand side where there'll be a blue button here that should say get the app, add the app, something along those lines. Once you click it, it's going to download the app for you. Mine says launch app because I've already downloaded it. So once you've already downloaded it, it's going to say launch app. And you can click on it and it pulls up a graphing calculator just like what we use in class. So it's really good to have on test and just something that you're familiar with to use on your test and your quizzes. Today we're going to go ahead and start by going over your Chapter 1, Part 1 test review. This test review is on Canvas, so if you go back to today's date, wherever you found the video, there's a link that says Chapter 1, Part 1 test review. You can go ahead and print that out, or you can just grab some paper and follow along with me. We're going to go through some questions that is similar to what you'll see on your test on Wednesday. So first one, find the slope. This is review from 1.3a, that last part of that section, and we're finding the slope. Slope, remember the equation, m equals y2 minus y1 over x2 minus x1. You're going to want to memorize that for the test, which you probably have because you've seen it since Algebra 1. But let's go label it. x1, y1, x2, y2. And now I'm just going to plug them into my formula. 2 minus 3 over negative 9 minus 1. Make sure to keep those minus signs there. 2 minus 3 is negative 1. Negative 9 minus 1 is negative 10. And that reduces to positive 1/10. So that is our slope of our line between those 2 points. Let's do number 2. Again, I'm going to label it x1, y1, x2, y2, and then just plug it in. 6 minus 5 divided by negative 1 minus 4. And simplify. 6 minus 5 is 1. Negative 1 minus 4 is negative 5. You can use a calculator if you needed to on these problems. We also want to make sure that they're reduced completely on your slope problems. And these are, so that's good. The next problem we're going to look at says write the equation of the line in slope-intercept form. This is from section 1.4, so you can look back at that section if you need to. Slope-intercept form, what was the equation that we used for slope-intercept form? Right, y equals mx plus b. Remember, b represents the y-intercept, m represents the slope. So let's go plug in what we know. I know my m, my slope, is 3. And I have an x and a y. But I don't know my y-intercept, but I can go find it. My y is 6. My slope, I was told, is 3. The x value I'm given is 1. Plus b. That's a b there, not a 6 at the end. Okay, so I plugged in my x and my y and the m. Now I'm going to go find b. 6 equals 3 times 1 is 3, plus b. Subtract 3 to both sides. 6 minus 3, just come over here, is 3, equals b. Okay, so I plugged in x, y, and the m to solve for b. Now that I've got my slope and my y-intercept, I can go put those together. Y equals, my slope was 3, x, my y-intercept is also 3. And that is your linear equation passing through that point with a slope of 3 in slope-intercept form. Let's go do number 4. Number 4 is a little bit different. We're still writing our equation in slope-intercept form, y equals mx plus b. I know two ordered pairs, x1, y1, x2, and y2. But I need to go find my slope and my y-intercept. Well, your y-intercept we need to save till the end because we can first, between two ordered pairs, we can always find our slope. So I'm going to plug it into that slope formula just like we did on up above. -6 minus 9 divided by 42 minus 17. You can use a calculator if you need to. -6 minus 9 is -15. And 42 minus 17 is positive 25. But you can reduce this, dividing both by 5. -3 is on top, and divide by 5 is positive 5 at the bottom. So that is my slope, which is great. Now I've got my slope that I can plug in here. My x and y, I've got two choices to choose from because I've got two ordered pairs, and it doesn't matter which one you pick. I'm going to use the one I used on your test review key, and I use this point. So my y is 9. My slope I just found was -3/5, and the x they gave me was 17 plus b. Okay. If you chose to use the other ordered pair, you'd have -6 equals -3/5 times 42 plus b. Okay, now we're going to go solve for b. 9 equals -3 times 17 is -51 over 5 plus b. Add 51 over 5 to both sides, just to get b all by itself. Then we end up with b equals 96 over 5. And there's the other missing piece. So I found my slope on the first step, found my y-intercept. Now I'm going to put them together. Y equals my slope, -3/5 x. My y-intercept, 96 over 5. And that is the linear equation passing through those 2 points. If you chose to use the other ordered pair, 42 and -6, that's totally fine. You should get the exact same equation as I did there. Okay, our next set of problems. Write the equation of the line in point-slope form. This is also from section 1.4 in our notes. Point-slope form, recall, is y minus y1 equals m, parenthesis, x minus x1. Okay, kind of like the other formula, y1, x1 are from your ordered pairs. M represents the slope. So we're going to plug everything in. My slope in the first one is m equals 2, passing through the point 3 and 4. So here's x1, here's y1. Now I'm just going to plug it in. Y minus my y1 is 4 equals my slope is 2, x minus x1 is 3. So you plug in your slope and the x1 and the y1 as your ordered pair. And that's all you have to do. Because I said point slope form, you can just stop there and that's good enough. Let's go and do the next one. On this one, I'm given two ordered pairs. What can I find between two ordered pairs? Right, I can always find the slope. x1, y1, x2, y2. So I know in ordered pair, I need to go find the slope. 3 minus 1 over 10 minus 5. 3 minus 1 is 2, 10 minus 5 is 5. And that's my m. Now I'm going to go plug it back in to my point slope form. I'm going to do both ordered pairs. It doesn't matter which one you pick. And I say that on the test review. It doesn't matter which ordered pair you pick for the point slope form. Y minus, using the first ordered pair, 1 equals, my slope was 2/5, x minus x1, which is 5. If you chose to use the second ordered pair, or you could get y minus y1 is 3 equals 2/5, because that's our slope, x minus 10, because that was the x value from that ordered pair, the last ordered pair. Okay, the next question says write an equation of the line satisfying the given condition. When you're writing the equation of a line, just assume that it's y equals mx plus b, right? That's the form of a linear equation. That's what we're used to seeing. So if I don't tell you what form to write it in, Just assume it's y equals mx plus b. Okay, so number 7. Our line passes through the point x1, y1, 7, negative 6, and is parallel to the line defined by 2x minus 5 equals 5y minus 4. Okay, so to know the equation of our line, y equals mx plus b, we've got an ordered pair x and y, which is good, but we don't know our slope. Well, think back to what it meant to be parallel. We talked about this in section 1.5 in this chapter. Parallel meant that our lines must have the same slope. So we need to go find the slope of this line. So I'm going to go over here and do that. 2x equals 5y minus 4. Well, looking at that, I can't tell right off what the slope is because y is not by itself. So let's go get y by itself. Add 4, add 4. 2x plus 4 equals 5y. To get y by itself, I'm going to divide everything by 5. 2 over 5 does not reduce, so I have y equals 2 over 5x plus 4 over 5. You have to divide both pieces by 5. Okay, now looking at my equation, I can clearly see my slope is the 2/5. And because they're parallel, this line must also have a slope that is 2/5. Okay, so that parallel part told us we needed to go find the slope by solving that equation for y. Now I've got a slope in an ordered pair, so I can go plug it in to find my equation. My y is negative 6 equals 2/5 is my slope. X is 7 plus b. And I'm going to solve. 2/5 times 7 is 14 over 5 plus b. Subtract 14 over 5 to both sides. You can use a calculator here because we're dealing with fractions if you want to use a calculator. But when you subtract, you should get negative 44 over 5. Okay, here's my slope. There's my y-intercept. I can put them together to get my new line. Y equals, my slope was 2/5 because they were parallel. X minus 44 over 5. And that is simplified. That's the equation of a line parallel because it has the same slope as this line. And passing through that ordered pair 7, negative 6. Okay, let's go ahead and try number 8. Again, we're writing the equation of a line, y equals mx plus b, passing through the point x1, y1, 6, negative 4, and is perpendicular to the line defined by x minus 5y equals 1. So I'm going to go ahead, and first thing I need to do is find my slope. Well, if my lines are perpendicular, remember those have opposite, reciprocal slopes. Reciprocal, remember, just meant take a fraction and flip it over. So opposite reciprocal slopes. First thing I need to do is go find my slope, which means I need to solve this for y. X minus 5y equals 1. You can find your slope by solving for y. So I'm going to subtract x from both sides. Negative 5y equals, I'm just going to flip that order back. Negative x plus 1. Divide everything by negative 5. Negative 1 divided by negative 5, remember there's a 1 there, is positive 1 over 5x. 1 divided by negative 5 is negative 1/5. So this is our slope, 1/5. Because they're perpendicular, though, I've got to take the opposite and the reciprocal. The opposite of 1 over 5 is just 5, negative 5. Okay, because it's opposite, one's positive, mine's negative, and flipped means I take 1 over 5 and just flip it to 5 over 1, which is just negative 5. Okay, so there's my slope. I've got an ordered pair. Let's go plug both of those in. My y is negative 4 equals my slope, negative 5. My x1 is 6 plus b. Negative 4 equals negative 5 times 6 is negative 30 plus b. Add 30 to both sides. Add 30 over here so that b equals 26. right? Negative 4 plus 30 is 26. I've got my slope. I just found the y-intercept. Let's go plug it in. My slope was negative 5x. Remember, it's perpendicular. My y-intercept was 26. So on these problems, you first need to go find the slope, and then you can plug in the slope and the ordered pair, just like we did above to find the y-intercept. And that's the equation of our line. Again, this is from section 1.5. If you struggled with these problems, go back and try some more of these on Delta Math. See how you do with these linear equations. Okay, last one's on this front side. We're finding the x and y intercepts of each equation. This is from section 1.3a, that first day we did 1.3. So as we look at number 9, remember to find the x-intercepts. Before we even start looking at our problems, let's review right quick. The x-intercept is where y equals, do you remember? 0. Good. And the y-intercept is where x equals, do you remember? 0. Good. Of the equation. So that's what we're going to use to go find the x and y intercepts of each piece. First one, number 9, the x-intercept. I'm going to do what my rule says, plug in y equals 0. Remember, this is y. It's our function notation. So if I plug in y equals 0, 0 equals the square root of x minus 2. I'm going to get x by itself, so add 2 to both sides. 2 equals the square root of x. Remember, to undo something that's square rooted, you square both sides. 2 squared is 4. And that's what x equals. So I'm going to write that as an ordered pair, 4, 0. My x was 4. My y value that I plugged in was 0. Let's go on the other side and do the y-intercept. The y-intercept is where x equals 0. So y equals, in place of my x, I'm going to put a 0 minus 2. The square root of 0 is 0, minus 2 is negative 2. So now I've got my ordered pair. My y-intercept, my x was 0. The y value was negative 2. And that is our x and y-intercept for that first one. Okay, number 10. Again, x-intercept, y equals 0. Y-intercept, x equals 0. So I'm going to plug them in. G of x, remember, represents y. My x-intercept, I'm going to plug in 0 for the y, so basically just set it equal to 0. 3x minus 12. I'm going to add 12 to both sides of my equation. 12 equals 3x. Divide by 3 on both sides, so that x equals 4. Okay, so my x-intercept, again, my y was 0, my x was 4. So that's the x-intercept. Let's go get the y-intercept. The y-intercept, I'm going to plug in x equals 0 and solve. Y equals 3 times 0 minus 12. 3 times 0 is 0, minus 12 is negative 12. So my y value was negative 12. My x value was 0. Y was negative 12. And that is where my y-intercept is at. Okay, let's go ahead and do number 11. Again, x and y-intercept. X-intercept, plug in y equals 0. So 0 equals x squared minus 6. Add 6 to both sides. 6 equals x squared. To get and undo a squared, I'm going to take the square root of both sides. Remember though, when you take the square root, you always get the positive and the negative version out. So x equals plus or minus root 6. So this actually, because it had a plus and a minus, this has two x-intercepts. It has root 6, comma 0, and it also has negative root 6, comma 0, because it had two x values, positive and a negative. I'm going to come up here and do the y-intercept, because I ran out of space down below. The y-intercept, I'm going to set x equal to 0. So y equals 0 squared minus 6. 0 squared is 0, minus 6 is negative 6. And that's my ordered pair. 0 for the x, -6 for the y. And those are x and y intercepts. Again, this is from section 1.3a. If you need to, go back and try those problems again, or go back to the quiz activity we did, the quiz online, and go through those problems, see if you can do them again. Okay, next problem, say find the domain and range of the function. This is from section 1.3b, that second part of section 1.3. We said domain is the x value that we look left to right. Range is the y value that we look from bottom to top. Remember, using interval notation, we use brackets for closed dots, parentheses for open dots, and infinities. Okay, so let's look at number 12. And I wrote out the graphs, or you have all the graphs here for you to look at. On your test, you'll either be prompted to use a graphing calculator or something like that. So I'm not going to expect you to memorize these graphs. You'll be able to graph them using a calculator on the test. Looking at number 12, f of x equals 1 over x minus 2. Finding domain. Domain, like I just wrote above, we look left to right. And if you look really close on this graph, you'll see it goes off to the left forever. So it goes to -infinity. And then I'm going to look on my graph as I move to the right, go down, down, down. You'll notice it gets closer and closer to this line. That looks like it's the wall that we talked about in class. And that wall is at the point 2 on the x-axis, so it stops at 2. Then it picks up on the other side at 2 with a parenthesis. The reason I'm using parentheses is because it's never going to touch that 2. That's why I'm using parentheses. And then I follow it off to the right with an arrow to +infinity. And that's our domain. -infinity to 2, union 2 to +infinity. You can also kind of see here why 2 doesn't work. Because if I plug in 2 here, 2 minus 2 is 0. 1 over 0 does not exist, right? Can't have 0 in the bottom of a fraction. So that's why it's undefined at 2, and I'm going to use parentheses there to show that it's undefined. Let's go do the range. Range, we look from bottom to top based on the y values. So I'm going to erase this so we can see our picture a little better. My y values. So I go from the bottom. It goes all the way down, so it goes from -infinity. Then as I follow my graph up, it keeps going up, 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 but you'll notice that it's also going to have a break right here at this line, which has a y value of 0. So I'm going to stop at 0, pick it back up at 0, and take it on up to +infinity. Okay, so that one went down to -infinity. It went up to +infinity, but it had a break right here at y equals 0. That's why I put parentheses at the 0. Also, if you think about it, if this is a y value, 1 divided by whatever this is, 1 divided by anything cannot be 0. So that's why I could never get a y value of 0, because I could never take 1 divided by whatever's in the bottom here and make 0. That's why I'm putting parentheses there. 13, k of x equals the absolute value of x minus 4 plus 3. Domain, again, left to right. Range, bottom to top, based on our y values, and domain is our x. So as I look at 13, domain. How far left does my graph go? How far right does the graph go? You can see better on your calculator. This does extend infinitely in both directions. So domain is -infinity to +infinity. Goes forever to the left, forever to the right. Let's do the range. The range is how far low to how far high. How far low is right here, and that has a y value of 3. And then how far high, it just keeps going on up. So it starts at 3. I'm going to put a bracket because that's where it starts. It has an actual ordered pair at a y value of 3. And then it keeps opening up and goes up to infinity. with a parenthesis. Remember, use parentheses for those infinity symbols. Let's go to 14. Again, domain and range. Domain, how far left, how far right. How far left my graph goes is right here. 1, 2, 3, it starts right there at 4. So it starts at 4. It has an actual ordered pair there, so I'm going to use a bracket. Then how far right goes off to the right to positive infinity. Just think about the graph. It is going to keep going to the right, so it does go to infinity. Let's go to the range. The range, how far high and how far low. How far low you can see is right here at 2. That's my y value of 2, so I'm going to use a bracket. And then it goes on up, up, up to positive infinity. So I'm going to use a parentheses there. Okay? So 4, because it was an x value of 4 right here, it's an x. My range had a y value of 2. That's why I used a 2 with a bracket there. Okay, next set is determine if the given graphs represent functions. This is from section 1.3a as well, talking about functions when it comes to a graph. Remember, a function is if no x repeats. We also call that the vertical line test, right, where I draw vertical lines through my graph. And since these are all graphs, the vertical line test is going to be the easiest thing to use. So if I draw vertical lines, you can see it's crossing once there, once there, once there, and once there. So each time it's only crossing once, which means no x repeats. So yes, this is a function. Number 16, same thing. I'm going to draw vertical lines, and you can see it's only passing once each time, which means yes, this is a function as well. Number 17, draw vertical lines. It's passing once, so yes, this is a function also. Last one, 18, draw vertical lines. Oops, crosses once here and once there. Since it crossed twice through one line, this is a no. It is not a function because the x value repeats there and there. Whatever that x value is, which looks like 2 from our graph, it repeated twice, which means it is not a function. Okay, last set of problems. Evaluate the given functions using g of x below. So this goes from also section 1.3a. We covered a lot in that section. And this is just evaluating. Remember from the first week of school, evaluate meant to substitute. So I'm going to take whatever my x is and substitute it into my equation. G of 2. G of 2 equals 2. Remember, in place of the x, I'm going to put whatever my x is, which is 2, plus 1, and simplify. 2 times 2 is 4, plus 1 is 5. So G of 2 is equal to 5. It's just purely plugging that x value into our function. Next one. My x value is negative 3. So g of negative 3, 2 times negative 3 plus 1. 2 times negative 3 is negative 6, plus 1 is negative 5. So g of negative 3 is negative 5. Next one, g of 0. G of 0, that's my x value, so I'm going to plug it in. 2 times 0 plus 1. 2 times 0 is 0, plus 1 is 1. So g of 0 equals 1. Last one, g of 1/2 is my x value, so I'm going to plug it in. 2 times 1/2 plus 1. 2 times 1/2 is 1, plus 1 is 2. So g of 1/2 was my x value. My output was 2 once I plug it in. That's the end of our test review. If you want to go back and rewatch this video or go through any more problems, I'd recommend doing some more problems on Delta Math, since that's where our homework came from a lot in this chapter. You can go back on and do some more Delta Math problems. Go back through, watch this video, whatever you need to do to help you get ready for your test on Wednesday. Just a side note, You will also need to review PEMDAS and factoring rules from Chapter R, because you're going to have 3 review questions from factoring that will be on your test on Wednesday. So I would recommend going back through those factoring rules, making sure you remember them well. I also posted another review activity for factoring, and I'll create a separate video for that one.